This is Algebra 1, Lesson 8.20 and Negative Exponents. So as a review of the rules we've learned so far with exponents, the first thing we learned is if you multiply two exponents that have the same base, what you're really doing is you're adding the exponents together. For example, if you have 3 to the second power times 3 to the seventh power, it's really 3 to the ninth power. You just add the 2 and the 7 together. If you have a power to a power, if you have a to the m to the nth power, what you're really doing is multiplying. For example, if you have 5 squared, or 5 to the second power, to the fourth power, it's really 5 to the eighth power. And one more, if you have a product, if you're multiplying things within parentheses and that parenthesis is to a power, don't forget to distribute. For example, if you have 2 times 3 to the sixth power, it's really 2 to the sixth power times 3 to the sixth power. Now we're going to investigate what happens if that exponent is a 0 or a negative. We haven't looked at that type yet. So to investigate, I made a little table. We're going to start with our base is 2, and we're going to take it to the third power, to the first power, second power, first power, 0, and then we're going to go into the negatives. So if we take 2 to the third power, that means 2 times 2 times 2, which gives us 8. 2 to the second power, which is 2 times 2 or 4. 2 to the first power, which is 2. What happens if you notice what's going on here? Let's go ahead and just write on here. So we said this is 2 to the third power, which we know is 2 times 2 times 2, or 8. This is 2 to the second power, which is 2 times 2. And this is 2 to the first power, which is just 2. If you notice what's happening, every time we're dividing it by 2. 8 divided by 2 gives us 4. 4 divided by 2 gives us 2. So the next one, we're going to take 2 divided by 2, and it's going to give us 1. Let's try it with 3. 3 to the third power, which is 3 times 3 times 3 is 27. 3 to the second power, which is 3 times 3 gives us 9. 3 to the first power gives us 3. And you can see what's happening every time. We're dividing by 3 this time. So if we divide 3 by 3 to get to 3 to the 0 power, it's going to be 1. Same thing with 4. Every time we divide by 4, so if we get 4 divided by 4, we're going to get 1. So you can probably see the secret is any exponent to the 0 power, any base to the 0 power is always going to give us 1. We call that the 0 power rule. Any non-zero number to the 0 power is always going to be 1. It's an easy one. All right, what happens when you get to the negative exponents? What you want to do is you want to take the reciprocal and then take it to that power. So our base is 2, which we know 2 is the same thing as 2 over 1. If we take the reciprocal, which means flip it upside down, that's going to make that 1 over 2. And now the 2 is to a positive. That's how we get rid of the negative, by taking the reciprocal. So that's just going to give us 1/2. This is 1 over 2. Now that I took the reciprocal, I'm going to make that negative 2 into a positive 2. And 2 to the second power is 4. And I'm going to do it one more time. To get rid of that negative on the 3, I have to flip the 2 over 1 upside down and make it 1 over 2. And now my power is positive 3. So that's going to give us 1 over 2 times 2 times 2, or 1 over 8. All right, so the secret with that one, you can see, it's called the negative power rule. If you take any negative exponent, what you want to do is take the reciprocal, and that would turn it into a positive. So example, if your base was a, it now is 1 over a, because we know a whole number is really over 1, and now the exponent becomes a positive as long as your a is not 0, because you can't have a 0 in the denominator. This gets a little tricky, so I just wanted to go over this. So a to the negative m, we're going to take the reciprocal of a, which is a over 1. So the reciprocal would be 1 over a. Now the m becomes a positive. But what happens if it's a fraction already? What if it's 1 over a to the negative m? The reciprocal, remember, means flip it upside down. So that's now going to be a over 1, and the negative m becomes a positive 1, and you know we don't really need that over 1, so that's a to the m. Okay, so if you see a negative exponent, you want to flip it upside down and then make the exponent positive. Let's practice. All right, my favorite right here, anything to the 0 power, we don't care what the number is always going to be 1. Okay, I don't even have to look at the base. All right, here comes those negatives. So we have 2 to the negative 4. Anytime you see a negative exponent, you want it to be a positive. So we're going to make that 1 over 2 to the positive 4. Okay, that's how we get rid of the negative. And 2 to the 4th power is going to give us 16. So that looks like our answer is going to be 1 over 16. And here's another one. 6 to the negative 1 is going to give us, we're going to flip 6 over 1, make it 1 over 6, and now the 1 becomes positive. You know, with an exponent of 1, it doesn't really mean anything, so we don't need to write it. And there we go. Let's get some tricky ones in here. All right, we're going to combine our rules from the 2 days. We're multiplying exponents with the same base. So we said, hey, when I do that, what I do is I add them together. So I take 7 plus a negative 9. That's going to give me 3 to the negative 2 power. And now today's rule, if you have a negative exponent, we're going to flip that 3 over 1 upside down and make it 1 over 3. Now that 2 becomes a positive. 3 to the 2nd power means 3 times 3, or 1 over 9. All right, here's that negative exponent. It's already in a fraction though. You know this really means 1 times 4 on the top, so this is really 1/4. So the way you're going to flip, if you want to think of it this way, the way you're going to flip that upside down, you're going to make it 4 over 1. Now that negative 2 becomes a positive 2. Okay, so we got rid of that negative by moving it to the top, taking the reciprocal. So now on the top, I have 4 times 4 to the 2nd power, which we know means 4 to the 3rd power, because we add those together. 1 plus 2 gives us 3. And 4 to the 3rd power, or cubed, is 64. All right, it gets even a little bit trickier. Here it is again. We're going to take the reciprocal. Don't let it trick you. If it's already a fraction, that's an easy one to flip upside down. So we have 4 over 5. Now that 2 is positive. We got rid of the problem. But don't forget that distributive property. What that really means is 4/5 times 4/5. You're going to distribute that squared, or the 2, to both of those things. So we have 16 over 25. All right, one last real tricky one. Here we're going to combine all of our rules together. We have 3 to the 0 power, so we know that means 1, and 1 times 2 is still 2. So we can just get rid of that. That's not going to make a difference to us. Here's that negative. We don't want that negative. So if it's a fraction, we're going to move it to the numerator. We're going to take the reciprocal. So we're going to move that to the top. So on the top, I already have a 2. We got rid of the 1. We don't need that. This 2, to get it to the top, we're going to move it up there, and now that 2 becomes a positive 2. So inside the parentheses, I have 2 times 2 to the 2nd power. Remember, there's really a 1 here. So that's going to give us 2 to the 3rd power. Now, here we go again, to the negative 3. Let's go ahead and simplify that. 2 to the 3rd power, I think we all know that means that's 8. And now we're going to take that to the negative 3 power. I just simplified the inside there, inside the parentheses. Whoops, mouse dropped. Okay, so now one more time, we got to get rid of that negative 3. So we're going to make it 1 over 8 to the positive 3. That's how I got rid of the negative. And I'm going to use my calculator. 8 to the 3rd power tells us we have 512, so my final answer is 1 over 512. That used all of our rules that we've learned so far. Please try the practice problems. Let me know if you have any questions. Thank you.